Okay, so we are gonna find the equation of the quadratic function using the standard form. Using the standard form. So it is possible to find the equation of the graph of a quadratic function if 2 points are given. If 2 points are given. So you can see there that these are the 2 points that are given. These are the 2 points that are given. So if 2 points are given, we use the standard form. We use the standard form. So what is the standard form? The standard form is y is equal to ax squared plus bx plus c. So this is the standard form. This is the standard form. All right, so our c, our c here happens to be our y-intercept. Okay? So this is y-intercept. Okay, so it happens to be our y-intercept. All right, so um, what we want to do is to use this standard form to find um, the equation of this quadratic function. All right, so we are going to determine the equation there in this form. Y is equals to ax squared plus c. So this is the form that we are going to use. So you can see that the graph is cutting the y-axis at the origin. This is the origin. You can see here where I'm putting a blue dot. The graph is cutting the y-axis at the origin and then also passes through 2 points as indicated on the graph. These 2 points that I'm also shading in blue. Okay, so the graph cuts the y-axis there at the origin and passes through the 2 points that are indicated on the graph. All right, so since the y-intercept is 0, the y-intercept is 0. This y-intercept here. So the y-intercept is 0. We know that c is going to be equal to 0. C is going to be equal to 0. Why? Because our y-intercept is 0. Our y-intercept is 0 because the graph is cutting the y-axis at the origin. So the y-intercept is 0. So if our y-intercept is 0, we know that c is also going to be equal to 0. So now we have managed to find our value of c, which is equal to 0. So let's sub in the value of c that we have just found into that equation. So our equation now becomes y is equal to ax squared plus bx. So we say that c is 0, right? So instead of writing c, I'm going to write 0. Okay, so we have first found the value of c, which is 0. Okay, so instead of writing 0, I can just shorten it and just write it as y is equal to a x squared plus bx. I don't need to write plus 0 because 0 means nothing. So I'll just know that the equation is going to be y is equal to ax squared plus, need to put a plus here, plus bx. So there's no zero, right? So what's going to be next? So I know that the equation is going to be in this form here. So what is going to be the next thing to do? The next thing to do will be to substitute the points. Substitute the points. Substitute the points. So I have these 2 points here that I'm circling in green right here. So these are the 2 points that I'm going to substitute. Okay? And when I substitute these 2 points, I'm going to get 2 equations. All right, so that I'm going to use to solve for my A and also my B right there. Okay, I've already found my C, which is 0, but I haven't found my A, I haven't found my B. So I need to find my A and find my B. So what I'll do is I'm going to substitute those 2 points. I'm going to substitute the 2 points. All right, so I'm going to start with this here. I'm going to start by substituting that point there. Okay, so I'm substituting the points into this equation here. Y is equal to ax squared plus bx. All right, so let's go. So in the place of y, remember this is my x, minus 1 is x, and minus 6 is y. So where there is x, I'm going to put minus 1, and where there is y, I'm going to put minus 6. All right, so let's go. So instead of saying, okay, let me just write it down one more time. The equation y is equals to ax squared. So this is the equation that I'm going to sub into. Y is equals to ax squared plus bx. Fortunately, we know we are not going to be having c because we already know that our c is 0. So anyway, it's fine. We are just going to sub it into this equation. So y is negative 6. So here I'm going to write negative 6 is equal to a. What is my x? My x is negative 1 there. So I'm going to write negative 1 squared plus b. Then in the place of x, I'm also going to put minus 1. Okay. All right. So this then simplifies to minus 6 is equal to a minus b. A minus b. Okay. So therefore, a minus b is equal to negative 6. So this becomes my first equation. All right, so my second equation, I'm going to be substituting this point here, 3 and 6. So let me use maybe a different color this time around. So y is equal to ax squared plus bx. This is the equation that I'm going to sub into. So what am I substituting? I'm substituting this point here, which I'm circling in red. So this is the point that I'm going to substitute into. All right, so 3 is my x, 6 is my y. All right, so where there is x, I'm going to put 3. Where there is y, I'm going to put 6. All right, so here this is y, so I'm going to put 6 is equal to a. So x is 3, so here I'm going to put 3 and squared plus b. X is 3, so I'm going to put 3. Okay, which then becomes 6 is equal to 9a plus 3b. I can actually simplify this because I can see that 3 is a factor here. So I can simplify it, divide everything there by 3. So this becomes 2 is equal to 3a plus b. All right, which I can then conclude and write it this way, that 3a plus b is equal to 2. And this is my second equation. So you can see now that I have got two equations here. I've got this equation and this other equation. So I've got two equations, and I still need to find my A and I need to find my B. So what I'm going to do is I'm now going to solve for A and B using simultaneous equations. Using simultaneous equations. All right, so I'm going to take A minus B. So I'm now solving simultaneous equation. I'm solving for A and B using simultaneous equations. All right, so this is minus 6. And the other one is 3. A plus B is equal to 2. Okay, so I'm just going to use elimination, all right? Just going to use elimination here. So I'm just going to add there. This becomes 4a is equal to negative 4. Okay, so therefore, I found my a. My a is equal to negative 1. So a there is equal to negative 1. Then now I find b. I find b by just subbing a. All right, I'm just gonna substitute a into this equation on top there. A minus b is equal to negative 6. So in the place of a, I'm gonna put negative 1 there. So this is gonna be negative 1 minus b is equal to negative 6. So therefore, I'm going to take the negative 1 to the other side. So I'm left with negative b is equal to, so this becomes negative 6 plus 1, okay, which is going to be negative b is equal to negative 5. Then I divide both sides by negative 1, then b is going to be equal to 5. So now I have both my a and my b. I have my A and my B. Okay, so now that I have my A, my B, and my C, which happens to be 0, of course, I'm now going to sub it into the equation again so that I can obtain uh, the equation that they want us to find, the equation of this quadratic function. Okay, so remember what we had this y is equal to it was ax squared, right? Yeah, it was ax squared. This was y is equal to ax squared plus bx. This is what we had. All right, so I now have my a and I have my b. So I'm just going to simply sub them into this equation, which is going to be y is equal to my a is minus 1. So I'm just going to put it as minus x squared. I'm not going to write it as minus 1x squared. I'm just going to write it as minus x squared. Then plus my b is 5 here. Then I'm going to just put 5x. So this is my equation. So remember, c is 0. So I was going to write my c, which is going to be 0, but there's no need for us to put 0 here, okay? There's no need. So we'll just leave it like that. Just leave it blank like this. So my equation is y is equal to negative x squared plus 5x. So that is the equation of this quadratic function, okay? That's the equation of this parabola. So that's how you apply the standard form when you are given only 2 points. When you're only given 2 points. So that's what you do. All right. Cheers. Bye bye.